In class, we will be talking about a special case of rectilinear motion. This is the motion of a projectile. The thing about motion of a projectile is that the gravity is always pointing downwards and as a constant value of 9.8 meters per second and 32 feet per second is of a foot-pound system. Okay, so motion of a projectile. So I'm drawing the XY axis. This is we are concerned with the motion of a particle, so there is no rotation and so on. It's just moving in the XY direction. The particle initially is at x0, y0, and then when you launch it with a speed, let's say v0, it moves in a parabolic fashion. So this is the path of the projectile. Okay, and this is because gravity points downwards and it is got a fixed values. This is constant. Okay, this is position at t equals 0. So this is a case of, this is actually called curvilinear motion, because the motion is in a curve. So we're going to use what we learned last time to do the kinematics of motion under gravity. The acceleration is 0I minus j, okay, where g is gravity and it points downwards. So there's a negative sign because it's in the direction, if you see this is in the negative direction of y. Okay? So g is gravitational constant. It is 9.8 meters per second square and it is 32 feet per second square. It depends on which units are you doing the problem. So similar to what we done last time, what we do is we try to find the position by integrating the acceleration twice and the velocity by integrating the acceleration once. So let's just find the velocity. So ax is 0. Ax is the x component of the acceleration, but ax is dvx dt equals 0. So integrating this gives me vx is a constant, or c. We call it c1. Okay, and what I know is that this is vx0 vy0 for the y. So t equals 0, vx is equal to vx0, so that is equal to c1. Okay. So vx is equal to vx0. Okay, next I want to find the position as a function of time. So in this case, I know that vx is dx dt equals vx0. So if I integrate that again, I would get x equals vx0 t plus c2. I know that at t equals 0, x is what? Let's see. X is right here, x0. So x is x0. So if I put that, we would get x0 is vx0 times 0 plus c2, which means c2 is x0. So x is vx0 t plus x0. Okay, what it means is that when you launch a particle in the effect of gravity, the x component of the velocity remains same, constant. It doesn't change with time. However, the x position changes linearly with time because the velocity is going to be constant. Okay, so for y0, I would want you to fill the blanks. Just going to write the final answer. Okay, I'll put the steps, but I want you to fill the blanks. So ay is minus g, and then I want you to derive, and if you can't derive, this is in the book, but you should be comfortable deriving this equation. So you should get vy equals minus gt plus vy0 and y equals minus gt square divided by 2 plus vy0 t plus y0. Okay, so this is giving me the position x as a function of time. This is giving me the position y as a function of time. Now, sometimes it's very useful to find x, y, the velocity as a function of only the distance and not the time, right? So this is the formula we did a long time back. It was, remember, v dv is x is ds. So dv, I had written down a. So remember we had written this formula v dv dx is equal to a, right? So we can use this formula to find an equation for the velocity as a function of distance, and this is particularly useful in the y direction. So if you put this is equal to vy dvy dy equals minus g, then you should be able to derive vy square is vy0 square minus 2g y minus y0. Okay, and I wanted to show this. This is again an initial value problem. By initial value, you're given the position at the initial position, and you're given the initial velocity. So you should be able to integrate this and get this expression. So you want to do that. And as I said, this is a very useful formula only if you're not interested in knowing the absolute time. If you know y0 and you know vy0, then you can find y as a function of distance moved. Any questions on that? Okay, let's do a question. Okay, so a ball is thrown horizontally with a velocity of 49 meters per second. Okay, and it's dropped from a height of 9.8 meters. Okay, gravity is pointing this way, 9.8 meters per second square. You got to find what the velocity is as a function of time, and then position as a function of time, and the time the particle or the ball takes to hit the ground. Can you try to do this? This is just a straightforward application of the formulas. How would you try to solve this problem?
velocity would have been 49 meters per second for velocity. Is that right?
This is 49 meters per second. Yes. Okay, so what's the velocity? Velocity is, let's try to write the expression. So what we know about the velocity is the velocity in the x direction is vx0 times t. Sorry, just that, right? And vy is vy0 t, what else, minus gt plus gt. Sorry, it's minus gt plus vy0, right? So all I need to do is sub in the value of vx and vy. So vx0. So what's the velocity in the x direction? 49. So vx is 49 meters per second. And what is the velocity in the y direction? What's the velocity? It's 0, right? Because this particle is launched with a velocity of 49 meters per second in the x direction. There is no velocity in the y direction. So vy is minus gt, and g is 9.8 t. Okay, now can you find the position? X. So x is vx0t plus x0, and y is see, should be y0 plus vy0t minus half gt square. So x0. So what's the initial position of the particle? So the x position is 0, right? Because this is 0 on the x-axis. So 0. So x is 49t. What's the y position of the particle? 9.8, because this thing here is 9.8, and this is the y-axis. So 9.8. So I can write y is 9.8. Sorry, yeah, 9.8 plus vy0, which is 0, minus half gt squared. So g is 9.8, so this is 4.9 t squared. Okay, so the third part is a numeric problem, which is you're going to find the time it takes for the particle to hit the ground. So at what time will it hit the ground? So what time it will be? So it'll go this way and hit the ground at some point of time. You got to find the time. Did anybody get the time? Time to hit the ground? How much? 1.4. Anybody else got a different answer? So let's check if this is the right answer. How will you go about solving this? What do you know about the particle when it hits the ground? Y is 0, right? So if we put y equals 0, in, let's say, in equation 1, then we should be able to get the time. So 0 is 9.8 minus 4.9 t square. So t is 9.8 divided by 4.9. So that is 2. Sorry, t square is this. And so t is square root of 2. So what's square root of 2? 1.4. So 1.4 seconds. Okay, I can add another question here. What's the find velocity when the particle hits the ground, and then distance x when particle hits the ground. Okay, so two more questions. Can you find the velocity when the particle hits the ground? So you have to find what's the velocity when it's right here. So you're going to find the x velocity and the y velocity. So did we get the x velocity? So the x velocity, if you can see over here, it's just constant. It won't change with time. It's not a function of time at all. So the x velocity would be 49. What is the y velocity? So we know that the y velocity is minus 9.8 times t, but we did determine the time. It was 1.4. So what's the y velocity? It's 9.8 times 1.4. 1.4. What's the answer? What did you get? Negative 14.7, 13.7. Okay. So the interesting thing is this value is negative, which means that it is. Remember, a convention was x is positive to the right and positive on upwards. So when the velocity is negative, it means that the particle is going downwards. Okay, and that makes sense. The particle is actually going downwards. And the final question is, we need to find x, or the distance from the x-axis when the particle hits the ground. Okay, so for that we can use this formula here. It says x is 49 times t, and we know what the time is. It's 1.4. So we can solve for x. Okay, so that should be, what's the answer? 68.6 meters. Okay. Now, if you're asked the magnitude of of the velocity, then how do you find the magnitude? It is the square root of Vx square plus Vy square. Okay. So in this case, I was pretty vague. I did not say magnitude. I just said velocity. So if I ask you to find the velocity, you better give me the x and y. If I ask you to find the magnitude, then you should do this. Here the question is, if a person is trying to basket a ball in basketball, then you got to find the velocity. He needs to launch the ball so that it will go inside the basket. And then you got to find the velocity when the ball is passing through the basket. So I want you to solve for VA, okay? And VA here is the magnitude. It's not Vx or Vy. You need to find the magnitude of the velocity. So it's just application of the formulas we had, and I probably solved a similar question just a while back. Anybody got the answer? Okay. So guys who are trying should try, but let me give you a hint. In this case, you kind of know where the ball should be, right? You know the x coordinate of the ball, and you know the y coordinate of the ball. You don't know the time. So if you can, so there is an expression for the x and y coordinate, right? Which will be a function of the velocity and time. So if you write these two expressions, you'll have, you know what x is, you know what y is, you'll be able to solve for velocity and the time. So it'll be two equations, two unknowns. Okay, so what's the velocity in the x direction? It's VA cosine of 30. So VA cosine 30, right? So VA cosine 30 degrees, and Vy0 is the velocity in the y direction. That's going to be VA sine of 30 degrees. So VA sine 30 degrees. So what else? So we know, do we know x0, y0? What's the initial position of the ball? So x is 0 because this is the x-axis. And the y0 is 1.5, that's right. So let's see. So we know the final position of the ball. It's 3, 10. 3 for the y and 10 for the x. We know x0, y0, vx0, vy0 as a function of va, and we also know g, that's 9.8. So let's write this as 10 equals x0 plus vx0 is va cosine of 30 degrees, and the other equation is 3 equals, oh, I forgot the time, thank you. Y0 is 1.5 plus VA sine of 30 degrees times t minus g is 9.8, so I'm going to divide it by 2. So 9.8 t square. That's it. So two equations and two unknowns. 4.9. So somebody got 4.9. Oh, thank you. My bad. Okay, so this is two equations, two unknowns, and you know the basic rule in algebra is if you have two equations, then you can solve for two unknowns, provided those equations are distinct. They are distinct, right? They're not looking similar. So we can solve for velocity as well as time using these two equations. What I would do is I would sub in the value of time as a function of velocity from one equation into the other and solve for velocity. So if you solve this, get solving to get time equals 0.9877. So here's something I can tell you for the exam. If you get to the point where you are able to, say, identify this and say that it's two equations, two unknowns, you'll probably get like 90% of the credit in the for the particular question. Okay. If you do it everything, you'll get full points. But really, what we're looking is how do you set up the problem? How do you go about solving it? So if you think of something is the right way, just spell it out on the paper. Don't just throw out 11.7 and throw out another answer. We want to see how you did the problem. So if you write 11.7 and there's nothing on the paper, there's no way I can figure out if you genuinely understood how to solve the problem. So you want to write things down, express yourself on paper for the exams, for any exams. Okay, so that's solving for the velocity. Now we want to find the velocity when the ball passing through the basket. Okay, so in this case, this is a similar question as last one, where I asked you to find the velocity when the ball hits the ground, right? You knew the time, so you could find the velocity. So what I'm going to do is I'm going to write the expression for the velocity first, and then it's just straightforward from there. Vx is Vx0. So Vx0 is the velocity in the x direction. That's going to be Va cosine of 30 degrees. Same thing I wrote earlier. Vy is going to be Vy0 minus Gt. So that's Va. The velocity in the y direction is Va times sine 30 degrees minus G is 9.8. And the time is going to be the time I just found, which is 0.9877. Okay, so if you do this, you get this comes out to be 10.13 meters per second, and Vy comes out to be minus 3.82 meters per second. Note that the velocity is negative, which indicates it's going downwards, which is the right thing. If you find that the answer is coming positive, when it should not. Like in this question, it is hard to, well, it is actually, yeah, it cannot, if you think of the problem in physical terms, if the ball has to go in the basket, it can, well, physically it should go from top, but when you're solving this problem, there's a chance that it may go from bottom, right? Because that physics is not there. You don't know that in this equation. So it's a good idea to keep a check on that. You want to think whether the answers you get make sense or not. So in this case, 3.8 makes sense. It's going to the basket from the top. So that's minus 3.82 meters per second. So what we're interested in this case is the magnitude of the velocity. That is going to be 10.13 square, the x component, plus the y component, which is minus 3.82 square. The square root of this whole thing is 10.83 meters per second. So that's the answer. Why is there what?
How does the change occur for the x component of the velocity? I guess why does it change?
What are you talking? Which part? Is this part 2?
I guess from being our initial velocity to now 2.13.
Oh, why is the velocity in the y direction change?
No, for the x component.
So the x component doesn't change because it is just going to be whatever you launch it with, right? In this case, we launched it with a velocity of VA cosine 30, and that's what it stays. So VA is 11.7. If you do cosine of 30, which is sine of 60.866, so 0.866 times that, you get 11.7. Sorry, 10.13. It doesn't change with time because there's no force acting or gravity acceleration acting in the x direction. As simple as that. Okay, any other question? How many of you play basketball? Okay, did you guys know that it's easier, you're more accurate when you shoot underarm than overarm? You want to agree with that? There was only one NBA player who did underarm shots, and he had an exceptionally high convergence rate.
There's a new one. He's a rookie. This year he started doing. He's like 80% with free throws.
I see.
From like 50.
I have a friend who also did a simulation study where he did overarm and underarm, and I think he also found that underarms, when you throw underarm, you're more accurate. But I think people take underarm to be like, it doesn't look cool, right? Overarm looks so cool. Anyway. Okay, so here's another question. I'll let you go after this, after we finish this. Okay, so for this question, this is a tennis question. So a ball is hit with a velocity VA, and this velocity is in the horizontal direction. Okay, the velocity VA is such that the ball just clears the ball, or the net, or whatever you'd like to say it. You got to find the horizontal velocity VA such that the ball just clears the wall or the net. Okay, and then once it clears the net, it hits the ground at some point and some distance s from the wall. You got to find that distance. Okay, so in the interest of time, I'll just start solving this. Okay, so what do we know? We know that the ball is going to clear the wall, right? So we know that x at some time, we don't know what the time is, it's going to be 3 feet. and y is going to be 21, well, it's going to be minus 21 feet. Oh, my bad. I messed it up. So, okay, for this question, there was no x and y, so I created my own x and y. I assume that the x, y is right here, and this was not in the original problem in the book. Okay, so x is the distance from this point here, and that distance is minus 21. It's not positive because it's on the negative x-axis. The y distance is the distance along the y-axis, and that is going to be 3. So this is the position of B, right? Position of B. Okay, we know that the velocity in the x direction is VA. We also know that the velocity in the y direction is 0 because the ball is launched in the x direction. Sorry, this should be minus VA. Or you could put positive or negative for things which are unknowns, and you'll see if you put, for example, if I put VA as VA and not minus VA, you'll see that the final answer will come out to be minus, which means that you actually launched in the negative direction. Let's just keep it as VA. Okay, so x equals x0 plus VAT, and y equals y0 minus, let me just write down the formula instead of skipping a step. So x0 plus vx0 times t, and then the y velocity is, y position is y0 minus half gt square plus vy0 times t. Okay, so this gives me x is minus 21 equals x0. I forgot to write x0, so let's just write that. Okay, x0 is the initial position of the ball, and that position is going to be 0, and the y position is the ball is hit from 7.5 in the x direction. So minus 21 is x0, which is 0 plus VA times t, and then y is 3 equals y0, which is 7.5 minus g is 9.8, so that's going to be 4.9 t square, and y0 is 0, so that second part is 0. So this is what's that?
Question is B.
Oh, the question
is 32.
Oh, good catch. 32. So 32 divided by 2, so that's 16. Good catch. Okay. Anything else? So it's this particular question it's quite simple to solve because you can solve for time from the second equation, and you can solve, once you know the time, you can solve for the velocity from the first one. So again, two equations, two unknowns. So time is, what I get is time is 0.53 seconds, and velocity A is 39.6 feet per second. So I was after the velocity, and that's the value. Okay, so the last question, and I'll let you go after this, is how to find, so you're going to find the distance s that the ball hits after the wall. Okay, so what you would do is, okay, I think I'm out of time. So I'm going to complete this later on, but I can tell you how I would go about solving this. What I would do is, I'll use the same thing I used earlier for the first question. I would find the distance from here right over here. So I'll find the total distance it takes for the ball to hit the ground by putting y equals 0. So once I find the total distance, then I can subtract out 21 to find s.